So, good morning, everybody. My name's Graham, and I'm on the client engineering team over at Airbnb. I am a testicular cancer survivor, and I've been in remission now for about 2.5 years. Since then, I've raised more money than I thought possible for Movember, and that is mostly thanks to the generosity of the Mac admin community. So if you find any of my talks, blog posts, or software useful, please consider donating. So really, this should be the title of the talk: How to Automate Yourself Out of a Job. I gave a talk several years ago about how you could automate yourself out of a job by not doing things manually. How to set the doc of a script, how to deploy profiles, that kind of thing. I think most of us these days get that for free with our MDM or management tool. So what kind of things do we need to automate these days? So life is nothing without goals. So what are our goals here? My personal goal is usually to get to the pub quicker, but you can replace that for whatever motivates you. So what is stopping us from getting to the pub quicker? It's things like writing and testing scripts, packaging, and various other repetitive tasks. So what on earth am I talking about when I'm talking about CI/CD? I'm talking about continuous integration and continuous delivery. So in a nutshell, you're going to have your code stored in a source control system. It's usually Git, but it could be something else like SVN or Mercurial. So every time you push code, a robot's going to run some sort of test on it to make sure the code's good before you merge it into the master branch. So why do you care about this? If you have robots checking the style of your code, everyone starts writing code in the same way. This makes it easier for other people to work on your code. If you have tests running on your code to make sure it doesn't break anything, you're going to have less outages. And if your team can make changes with a higher degree of confidence that they're not going to break anything, you're going to get more people wanting to make changes. So let's look at this from a nuts and bolts perspective. When you check your code into a source control tool like GitHub, it's going to send a webhook to your CI system. It's going to be talking to a master server or a controller. The master will then send the work out to one or more slave nodes to actually do the job. The job might be linting your code, might be running tests on it. It could be all sorts of things. So there are probably hundreds of CI/CD systems. I'm going to talk about a few that I've personally used. So first up, you've got Jenkins. It's an open source project, and you can host it yourself. So if you have absolutely no budget and loads of time, it's an okay option. So next up, we have BuildKite. It's a commercial option, but you have to bring your own build node. The logic mostly lives on the control server, so the build nodes are very easy to configure. And it means that your source code never leaves your infrastructure if that's something that matters to you. And lastly, we have CircleCI. They're also a commercial option, but they, like BuildKite, offer a free tier for open source projects. One of the nice things about CircleCI is they not only have hosted Linux build environments, they also have macOS VMs, which is useful when you're working on Mac-related things. There are other options here. Both Google and Amazon have build tools, so if you don't need to do Mac-specific things and you already have infrastructure on those clouds, then they're both really compelling options. And GitHub also have recently released actions, so you don't actually need to leave GitHub to perform your CI these days. So we're going to write a shell script. We've got this sweet bash script. It's super complicated. I'm sure no one can follow this. But then we decide we might want to use hello world elsewhere. So we move it to a variable. And this looks pretty reasonable from a first glance, right? But then we run shell check on it. Shell check is a linter for your shell scripts. It quite rightly tells me that I've been very stupid here. And it also tells me how to fix my code. So we're going to make the suggested changes, push the code, and all's well with good. All's good with the world. Except we've only solved the problem for us. What happens when we forget to run shell check when we're pushing code in a hurry, desperate to get to the pub? What happens when your colleague does exactly the same after they've spent an afternoon on the beer? At best, you're going to have to point out what they've done wrong during a code review. At worst, you're pushing broken code, which could cause a production outage. So let's see how this works in practice. We're going to follow a usual Git workflow. We're going to diff our work to check our changes. We're going to add them. Then we're going to commit them to Git. And then we're going to push it up to GitHub. So then we're going to click on the link that GitHub gives us in our terminal, and we're going to create a pull request from that. And we can see that we're failing CI, which is wonderful. So we can even click on details in GitHub and see what's broken. We get the same output that we got from running shell check manually, but we didn't need to do any extra work on locally before we pushed our code to get this check. So we're going to go back, fix our code, diff it, add it to Git again, commit our fix, repush it. Then we can head back over to GitHub, and we see all happy green check marks. Everything passed all the tests. So we can merge our code with more confidence. So it's simple enough to check for style and things like that. But how do we know the code's actually going to do what we want it to do? To actually confirm the code does what you want, you're going to need to write some tests. So let's consider this script. It looks pretty reasonable. It's just parsing the output from a shell command. It's going to pass our linter, so we're good to go, right? So I stole this quote from Wikipedia. In computer programming, unit testing is a software testing method by which individual units of source code, sets of one or more computer program modules, together with associated control data, usage procedures, and operating procedures are tested to determine whether they're fit for use. So sometimes I feel like I could definitely use some more unit testing to determine whether I'm fit for use, but I digress. Python has unit testing built in. So we've got some very simple tests here. We're going to import our function and pass some sample input to it to make sure we get out what we expect. Oh, I guess I didn't actually fix it. Unfortunately, this is pretty easy to correct. So black here, you see in some of the checks, well, the check that was successful, black is a Python linter. It's performing exactly the same function that shell check did in our last example. We choose details in GitHub, and it takes us to Circle CI, and we can see exactly where we're going wrong. False, the string, is not the same as false, the Boolean. So we can correct our bad code, push it, and be confident that our code is formatted in a consistent style and that we don't introduce any regressions. And this not only makes it easier for us to ensure our own code is higher quality, but allows others on our team to contribute with more confidence that they won't introduce any issues. So we know how to integrate our code. What about the delivery part? What are some things that we need to do every day? Eventually, we're all going to need to make a custom package for macOS. We have a script we need to deploy. Maybe we need to deploy wallpapers, that kind of stuff. The problem with packaging by hand is that you need to make sure you have all the right bits in the package. You bump the package version, you set the package identifier, then you have to build the package by hand. It's all kind of boring. So take this shell script. It's going to build a package from a directory of wallpapers and deploy a script that will be run by outset that's actually going to set the wallpaper. The only semi-complicated thing here is that the package version will be automatically set to the number of commits in the repo. So it's always going to go up. So let's have a look at the CI workflow. We're using two different steps here. The first one is that we're going to build the package for us. And then we've got another one that's going to upload it to an Amazon S3 bucket. So we can distribute it or feed it into other tools, such as Autopackage. The important part here is at the bottom. We are treating our master branch as our release branch. Nothing's going to touch this branch that isn't ready for production. This means that we want to build the package, whatever happens, whatever branch you're on. But we only want to upload it to our S3 bucket when the pull request is merged into our master branch. So we've got our pull request open. And if we head over to Circle CI, we're going to see that our build package job run, but the upload job did not. So we go into the job and we can see it spinning up a macOS VM. We can see it checking out our source code. And we can see it building our package. So let's head back over to GitHub and merge our PR to master. So if we head back to Circle, you can see our job running. The build package job is running, same as before. But if we go back, we see now that our upload to S3 job is going to run. This is actually going to run in a Linux container, since Linux containers are much faster to provision than macOS VMs, and you don't actually need macOS to upload a file to S3. So we're running through our jobs. The first one is to install the AWS CLI, and this is going to take the longest. It's completely lying to us when it says the ETA is 1 second. Still spinning. And then it's going to upload our package to S3. That's how we can get a package from source control straight up to S3 by CI. So scheduled tasks are all something we have to run at some point. If we're running on macOS, we'd usually run them by our launch daemon. If we run them on Linux, we'd probably use cron. But either of those involves having boxes running somewhere that's going to run the tasks. And that means keeping them patched, powering them in a data center, working how you're going to deploy your code to those boxes, and then keeping said code up to date. In other words, it's boring and tedious, and it's keeping us away from our goal of getting to the pub. So most people just run auto-package by hand. If you're fancy, you can use a launch agent or auto-packager. But you still need to run it on macOS. And you probably don't have any automated way to catch errors or to create pull requests to get your new software into your monkey repo. So far, all we've done is perform actions on one single repo. There's nothing stopping us from performing actions on other repositories as well. So here's going to be our basic workflow. Our job's going to run on a schedule. Might be every minute, might be every hour. It doesn't really matter. Our job's going to run auto-package, and if there are new packages, it's going to push them up to GitHub and create a new pull request. Then we're going to have a job on the target repo, i.e. our monkey repo, that's going to lint the changes. This could be as simple as making sure that the plist are valid. It could be as complicated as making sure that the package is actually installed correctly. This means that an admin just needs to review the PR and click a button to get the package out to the fleet. We would have a job running on master that uploads the repo to S3, just like we did in the last example. And if something goes wrong, the whole history of the repo is in Git, so we can just revert the commit. So here's our TLDR. Using test and linting helps keep errors low and maintain a consistent style to your code. This allows you to work faster because you have more confidence in the code that you're deploying. Using continuous delivery means that you don't spend your time producing packages or performing other busy work. All this means that we can get to the pub quicker.